Hi guys, this is Dr. G here, and in this video we are going to talk about the chemistry of gases. And specifically in this particular video we are going to talk about three gas laws that will determine the state of a gas. So the three laws that we are going to talk about in this video are known as Boyle's law, Charles' law, and Gay-Lussac's law. So in this video, we will talk about three laws separately, but of course, we will also talk about how to use these three laws in order to do calculations in chemistry. And also, we will talk about the similarities and differences between these three laws. Okay, so in the first law, we are going to talk about Boyle's law. Okay, so by now, you know that there are four characteristics that can define the state of a gas. So these four properties that can define the state of a gas are known as pressure, temperature, volume, and the amount. Okay, so these are the four properties that will define the state of a gas. So using these three laws, what we are going to do is we are going to always keep the amount of a gas constant, and also we are going to keep one of the three other constants constant as well. So basically we will keep the amount of a gas constant, and also we will keep one of the three other properties constant, and then we will try to change one of the other remaining properties and then see how the other property is going to change with respect to that. Okay, so the first law that we are going to talk about is called Boyle's law. So this Boyle's law talks about the pressure volume relationship of a gas at constant temperature and the amount. Okay, and in here, okay, in this law, so basically to understand the chemistry of this law, what we can do is we can take a piston for an example, and remember that this is a closed container. Okay, why do we need a closed container? Because as I mentioned earlier, we need to keep the amount of a gas constant. Okay, if you want to keep n, or the amount of a gas constant, what we need to do is that we need to make sure that no gas is going to come in or escape from our container. So to do that, we are going to use a closed container. So the other thing that is constant in Boyle's law is the temperature. Okay, so in Boyle's law, we are also going to keep temperature as a constant. So basically, that means we are doing this experiment, let's say, in room temperature or in a fixed temperature situation. Okay, so if you have, or if you can find an empty syringe, okay, what I want you to do is I want you to fill this empty syringe with a certain amount of gas. Okay, so let's imagine that this is your syringe. Okay, here is your syringe. Okay, and then how do you fill a certain amount of gas? You will basically pull the piston. You will pull the piston back and then fill some gas. Okay, so in here you are going to find your gas inside the piston, right? And then how do you make it closed? You can easily close the tip using your finger. Okay, use your finger and close the tip. Okay, close the tip of the syringe. Okay, so in this syringe you have a certain volume of a gas. Let's say you have 10 milliliters. Okay, so in this syringe you have, let's say, 10 milliliters of gas, and of course it is a closed container, and then we are not changing the temperature, so we can say that it is the same temperature. So temperature is a constant. So in this syringe you have 10 milliliters of gas at, let's say, atmospheric pressure, because we didn't apply any pressure to it, right? We didn't apply any pressure to it. Next, what I want you to do is I want you to press the piston inside and reduce the volume by half. I want you to press the piston, okay? Press the piston inside and reduce the volume of the container by half. Okay, so let's say the new volume is 5 milliliters. But when you are pressing the container, or when you are pressing the piston inward, what do you think you feel in your finger? You might feel like, okay, your finger might feel a lot of pressure, right? Your finger might feel a lot of pressure when you are pressing the piston inside. Your finger might feel a lot of pressure. So basically, if you have a container of gas at constant temperature, and if this container is a closed container, when you reduce the volume, pressure is going to increase. So basically, we can say that at constant amounts and constant temperatures, pressure is inversely proportional to volume. Why did I say that? Because when you decrease the volume, pressure increased. Or if you increase the volume, pressure decreases. Okay, so this is what we learned from the simple experiment that we did using a syringe, right? Pressure and volume is inversely proportional. Okay, so in math we don't like this proportional sign, right? We couldn't do any calculations using the proportional sign. So what we need to do is we need to replace this proportional sign with an equal sign. If you have an equal sign instead of a proportional sign, we can do some calculations, right? So that is exactly what we are going to do. We are going to replace this proportional sign, we are going to replace this particular proportional sign with an equal sign, but here is the catch. Just because you want to replace it, you can't just put an equal sign. Okay, the equal sign comes with a constant. Let's call it k. Okay, so we just replace the proportional sign with an equal sign, but it came with an equal sign. It came with a constant, I'm sorry. So basically now we know that pressure is equal to a constant times 1 over V. This is the equation that we have from our relationship. And of course, K is a constant. K is a constant. K is a constant. And here is the thing, okay? So let's take V to the other side. If you want to take V to the other side, you can cross multiply V, okay? You can cross multiply V and we will come to the top, okay? So what you have is PV, P times V equals K. This is what you have now. So what does this mean? What does this simple equation means? The product of pressure and volume is a constant. Or in other words, the multiplication of pressure and volume is a constant. Did you get that? The product of pressure and volume is a constant. So that is what we learned. So basically, according to Boyle's law, at constant temperatures and constant amounts, okay, pressure times volume is a constant. Okay, is a constant. So rather than using this equation like this one, we can rearrange this equation for two scenarios. So basically, P1 V1 equals P2 V2. Why can we write this equation? Because we know that the multiplication of product and volume for one state is going to be equal to the pressure and volume of another state. Okay, so therefore we can come up with a new equation called P1 V1 equals P2 V2. So this equation resembles Boyle's law. Okay, so basically this is Boyle's law. Okay, P1 V1 equals P2 V2. So if you consider a sample of gas at two situations where you keep the gas constant temperatures and amounts, and when you change the pressure, it will decrease or increase the volume. But if you multiply the pressure and volume, that is going to be equal to the new pressure and volume of the system. It is going to be equal to the new pressure and volume of the system. So in this example, your P1 is 1 atm, V1 is 4 liters, and then P2 is 2 atm, and then V2 is 2 liters. So as you can see, in both these states, in both these occasions, you will get the same value. So in this Boyle's, or you might want to remember this particular equation. Okay, all right. So let's do a simple calculation. Okay, so according to Boyle's law, once again, the pressure times volume is a constant, so therefore we can apply this to two different scenarios, or two different states where P1 V1 equals P2 V2 at T and N constant. Okay, at T and N constant. So this Boyle's law can be related to our health. Okay, can be applied to our breathing. Okay, so basically breathing, when we are breathing in, let's say that the temperature is not changing in the atmosphere. Okay, so your lungs expand. When lungs expand, that means the volume of your lungs increase. So when the volume of your lungs increase, what happens is that the pressure of inside your lungs decrease. The pressure inside your lungs decrease. So therefore, in order to justify the decrease in pressure, the air from outside will go into your lungs. So during inhalation, you are expanding your lungs. By expanding, you are increasing the volume, which results in a decrease in pressure. So therefore, the air will travel from high pressure outside to low pressure inside of your lungs. Okay, so that is how the inhalation occurs. And of course, the exhalation is the opposite, right? So during exhalation, you decrease the volume of your lungs, which means the pressure inside your lungs is going to increase. So when pressure inside your lung is high, air will travel from high pressure lungs to the low pressure outside. Okay, so the air will flow from higher pressure lungs to the outside. So basically, inhalation exhalation example is a prime example for Boyle's law. Okay, it's a prime example for Boyle's law. So basically, here's the stepwise guideline to use Boyle's law. So basically, you may want to read through it if you have to. But basically, what happens in here in Boyle's law is that if you know the equation P1 V1 equals P2 V2, you will know 3 of the 4 terms in the equation, and then you will have to figure out the unknown by using the 3 terms. Okay, and here is a nice example. Okay, here is a nice example. So what I want you to do is, I want you to read this example and then pause the video, and then see if you could figure out the answer without looking at the solution which is given in this slide. Okay, so in here you have a gas called ferron 12, okay, which is CCl2F2. Okay, and this gas is used in a refrigeration system, which has nothing to do with this calculation, by the way. Okay, so what happens is that what is the new volume of a 8 liter sample, okay, of gas initially at 500 millimeters of mercury pressure, after its pressure is changed to 2200 millimeters of mercury. Okay, so this is what happens. So let's talk about it one more time. Let's write down the terms that we have. Okay, so in here it is given that temperature is constant, and of course the amount is constant because it is a closed container. So N and T are constant. Whenever we know the constants, we know we know which law we have to apply. So if N and T is constant, we can apply the Boyle's law. Which is P1 V1 equals P2 V2. So this is our Boyle's law, right? So what do we know about the first situation? Okay, initial state. We know the volume, which is let me check the volume. So the volume is actually 8 liters. And then the pressure is given, P1 is given, which is 550 millimeters of mercury. Okay, millimeters of mercury, excuse me. Here's the pressure. And also P2 is given, which is 2200 millimeters of mercury. Okay, so you have to figure out the unknown term, which is V2. The unknown term, which is V2. So this is what you need to figure out. Okay, so without, I mean, we have an equation. Don't just jump into, plugging in the terms that you know. Okay, so let's analyze it. So what happens here is that you're trying to increase the pressure, right? So you're increasing the pressure from 550 to 2200. So you are increasing the pressure. So if you are increasing the pressure, what should happen to the volume? It should decrease or increase? It should decrease, right? If you are increasing the pressure and volume are inversely proportional, so volume should decrease. So basically in here you are increasing the pressure by 4 times. You are increasing the pressure by 4 times, so your volume should be decreased by 4 times, right? Why? Because pressure and volume has a inverse proportionality. So if you increase the pressure by 4 times, the volume should decrease by 4 times. So the correct answer is 2. Okay. So the new volume will be 2 liters. But if you don't understand that, that is fine. Okay. Just plug the numbers. Okay. So what you need to know is that you need to solve this equation, this Boyle's equation for V2. So once you solve this equation for V2, that means you want to rewrite this equation as a function of V2. So you need to get rid of P2. So you will cross multiply. So P2 is a numerator now. So when it goes to the other side after cross multiplication, it will be a denominator. So P1 V1 is unchanged, and then you will have P2 at the bottom, right? P2 at the bottom. So P1 of course is 550, okay, millimeters of mercury. Always write units, okay, it will pay off. And then volume is 8 liters. Then P2 is 2200 millimeters of mercury. So you will see that the units will cancel off, especially millimeters of mercury will cancel off, okay, and this is 4 times as, so you will divide 8 by 4, which is 2.0 liters. So V2 is 2.0 liters. That is how you solve this calculation. So of course I think I have given you the stepwise method to do this calculation. So if you want, you can pause the video and take a look at it. But I mean, it is simply just substituting the 3 known terms and then figure out the unknown term. Okay, figure out the unknown term. Here is the next calculation that we have. Okay, so pause the video and see if you could solve this one. Pause the video and see if you could solve this one. So in this calculation, guys, what we have is a sample of oxygen gas, and the volume and pressure is given. Okay, volume and pressure is given, and then they are changing the volume to 36 liters, and they are asking for the new pressure. All right, so and also they are telling us that N and T are constants. Well done, good. So if N and T are constants, we know that we can use Boyle's law. Okay, so that is the law that we will be using if the N and T are constants. So what is the Boyle's law? P1 V1 equals P2 V2. P2 V2, right? So in here we know all the terms but P2, right? We know all the terms but P2. So we have to rewrite this equation as a function of P2. So get rid of V2. So send it to the other side through cross multiplication. So it's a numerator now. It will be a denominator. Okay. So P1 V1 divided by V2. Okay. So this is our new equation as a function of P2. And then P1 is 600 millimeters of mercury. And then your V1 is 12 liters. Yeah, 12 liters. And V2 is 36 liters. So you are increasing the volume, so pressure should definitely decrease, right? You know that now. And your volume is increased by 3 times, so pressure should decrease by 3 times, and the correct answer is 200 millimeters of mercury. Okay, so the answer is A. The answer is A. All right, so here's the breakdown of your answer. So if you want, you can pause the video and take a look at it, but it is a very straightforward question. Okay, so now you should be able to do this study check by yourself. Okay, read and see if you could get the answer straight. Okay, once again, in this study check, N and T are constants, which means you should use Boyle's law. I mean, by now it is easy because you only know Boyle's law, right? So I couldn't give you calculations from anything other than Boyle's law, right? But in the future, when you learn 4 5 laws, and then you will have to think which law to be used, right? Then knowing these constants will help. So basically, constants will guide you to pick the correct equation. So when n and t are constants, of course, close your eyes and then use Boyle's law, right? So this is the study check. Try to do it by yourself, and here are the solutions. Okay, and then I have another calculation for you guys. Okay, I have another calculation for you guys, which is basically very similar to the previous calculations. Once again, you know a v1, and you know p1. Okay, you know p1, and you also know p2. Okay, so you need to rearrange this. This is Boyle's law. Why? Because constant t and n. So you have to rewrite this equation as a function of v2, which means v1 p1 divided by p2, right? So if you solve this equation, you will get the correct answer. And of course, in here, the pressure is decreased. So basically, if the pressure is decreased, the volume should increase, right? So there is only one possible answer. You don't even have to do any calculations. There's only one possible answer, which is answer C. Okay, here are the calculations if you want to take a look at it, but it is basically a very simple question. Okay, sometimes you don't even have to do calculations if you understand the law. All right, so I want you to do this study check without my help. Okay, see if you could try this one. Okay, here see if you could try this one by pausing the video. All right, these are the solutions. And next up is Charles' law. Okay, so basically in this law, we are going to talk about the relationship of temperature and volume. So in Charles' law, we are going to talk about the relationship between temperature and volume. And of course, we have to keep the other two properties constant. That means N is always a constant in all these 3 laws. And also we are going to keep pressure a constant. So we are going to keep P and N constant, and we are going to see the relationship between temperature and volume. Okay, we are going to see the relationship between temperature and volume. All right. In Charles' law, let's try to derive an equation for Charles' law. Okay, let's try to derive an equation for Charles' law without looking at the answer. Okay, I try to derive this because some people tend to understand this equation better when they derive the equation. Okay, so in Charles' law, you know that N and P are constants. N and P are constants. Okay, so let's imagine a balloon. Okay, Okay, so a balloon has a certain volume, of course, and then what you need to do is you need to change the temperature of this balloon and then see what happens to the volume, right? So if you have ever tried this balloon, if you ever tried putting a balloon in a fridge for a few minutes, you will realize that once it is inside the fridge, it shrinks. Okay, once the balloon is inside the fridge, it shrinks. So basically, when you decrease the temperature, the volume decreases. And this is always a common occurrence on a sunny day. If you take a inflated, I mean, if you take a balloon outside, okay, uh, it tend to pop after a few minutes. Why? Because at high temperatures, the molecules inside the balloon, they get more energy because of high temperatures, and then they start the balloon starts expanding, okay, and because of that it pops. Okay, so when temperatures are high, balloon expands. When the temperatures are low, the balloon uh, basically shrinks, right? So you can remember it like this: hot things expand, cold things shrink. Okay, so which means temperature and volume. Okay, temperature and volume has a proportional relationship. Okay, when one is high, the other one is high. Okay, when the temperature is high, the volume is high. When the temperature is low, the volume is low. So volume and temperature has a proportional relationship. Okay, proportional relationship. So basically we can write the relationship like this: volume is proportional to temperature when the n and p of a gas is constant. But we know that we don't like proportional sign. We need to substitute it with an equal sign, but it comes with a price. It comes with a constant, right? It comes with a constant. That is how you easily understand these things. So we didn't do anything to volume and temperature. So v is right here, and then here is temperature. Okay, so let's take temperature to the volume side. Okay, so it's a numerator now. So if you cross multiply it, it will be a denominator. So the ratio between volume and temperature is equal to what? A constant. K is a constant, guys, right? So the ratio between volume and temperature is always a constant at constant pressures and amounts. Okay, at constant pressure and amounts. So this is the equation that we got. But I mean, we can rewrite this relationship to two states of a gas at constant pressure and amount. Okay, we can rewrite this as V1 T1 equals V2 T2. Okay, this is the new equation for Charles law. So you might want to remember this equation, or you can derive it. By using the simple example that we got. Okay, so you can either learn to derive it, or you can remember this. I mean, both ways are fine, but I don't advise remembering everything. Okay, because in the exam with pressure you might get confused. But I mean, here's something important that you need to know. Okay, in physical chemistry, which gas chemistry is, okay, temperatures has to be in Kelvin. Okay, T should be in Kelvin. Okay, so that is important. Okay, don't use Celsius or Fahrenheit. Okay, you should always convert your temperatures to Kelvin. You may ask, how should I do that, right? How do I convert temperatures to Kelvin? So if you remember, okay, you take this temperatures in centigrades. Okay, let's say your temperatures are in centigrades, and you add 273.14. Okay, anyway, you add 273 to Celsius temperatures, and then you will get the Kelvin value. Okay, you will get the Kelvin value. That is how you convert the Celsius into Kelvin. Okay, and in this equation, make sure to convert all your temperatures to Kelvin. That is something important. Okay, that is important. So whenever you have temperature terms, always use Kelvin. Always use Kelvin, guys. Okay, and next up, let's move back to our presentation. And once again, we just learned how to get this Charles law equation at constant P and N. Okay, B1 over T1 is equal to B2 over T2. Okay, so that is Charles law. Okay, so let's see if you could apply this Charles law and do some calculations. So the simplest form of calculation will always be where I will give you 3 of the 4 terms, and you will substitute the 3 terms and figure out the unknown term. Okay, figure out the unknown term. But what I noticed is that most people don't know how to rewrite this equation. Okay, how to rewrite this equation as a function of a certain term. Okay, so in order to understand it, let's try to rewrite this equation b1 t1 equals v2 t2. Let's rewrite this equation as a function of t2. See if you could do it without my help. Rewrite this equation as a function of t2. All right, so how do you rewrite this as a function of t2? Okay, so you want to make sure that you isolate t2, right? You want to make sure that you isolate t2, so you need to get v2 to the other side. You can cross multiply. Okay, if you cross multiply, what you get is 1 over t2 equals v1 t1 and v2. Okay, 1 over t2 is equal to v1 divided by t1 and v2. Okay, but I mean, this is 1 over t2. We want this equation as a function of t2, right? So we have to flip this equation upside down. Okay, so it will be t1 times v2 divided by v1. Okay, so this is how you do it. So always make sure to correctly rearrange the equations depending on the unknown. Okay, depending on the unknown. Let's do a simple, I mean, I have another example here. Okay, I have rearranged this function as a function of v2. Okay, so this is how you do it, right? So you might want to go through that as well. All right, so we already did that. Actually, I didn't realize that I have this slide here. Okay, so if you want to write this function as a function of t2, you want to isolate t2 in one side and bring it to the top, right? So when you do that, the equation will be t2 equals t1 and then what? t1 t2, so t1 v2 divided by v1. Okay, divided by v1. Okay, this is how you do it. All right, this is the solution. And let's go through this sample problem. I mean, this is a detailed calculation. Okay, in here what we are doing is that we are changing the temperature of a balloon. Okay, so in the beginning the balloon was at 21 degrees Celsius and we are dropping the temperatures to 0 degrees, so you are decreasing the temperature. So volume should also decrease. The starting volume is 785, so volume should also decrease. Okay, so let's talk about the known terms. We know the V1, which is 785. We know T1, which is 294 Kelvin. Pay attention, guys. Okay, we have to convert Celsius to Kelvin by adding what? 273. T2 is 273 Kelvin. Okay, K is missing anyway, and then we have to figure out V2. Okay, so let's do this. So to do that, first of all, you need to rewrite this equation as a function of V2. So here the same equation in Charles' law as a function of V2, and then plug the knowns, and then you will get your answer in milliliters. Okay, you will get the answer in milliliters. All right, so let's see if you could do this one. Okay, in this study check, what you have is a sample of oxygen gas. Okay, a sample of oxygen gas, and in here you know the volume and temperature. Okay, you know the volume and temperature. So this is your V1 and here is your T1 in Celsius. We don't want it in Celsius, we want to convert it into what? Kelvin. So 18 degrees Celsius is what? 291 Kelvin. Okay, remember that. Okay, remember that is important. So you know T1 and also you know V2. What has happened to V2? The volume has increased, right? If you want to increase the volume at constant P and N, you should increase the temperature. Okay, you should increase the temperature according to Charles' law, right? According to Charles' law. All right, so let's do this calculation. So we are looking for T2. T2 equals what? T1 V1 times V2. So we already derived this, right? So let's plug the numbers. Temperature is 291 Kelvin. volume is, so V2 is 640 milliliters divided by V1 is 420 milliliters. So this will get you the temperature in Kelvin. This will get you the temperature in Kelvin. Okay, so I think the temperature in Kelvin is 443. Okay, so you look at the answers, no, answers are in Celsius. All the answers are in Celsius. So you need to convert this back to Celsius. You want to convert this back to Celsius. So T2 will be what? 443 minus 273 Celsius. Okay, which is 170. So the correct answer is B. Okay, correct answer is B. Just because you saw the correct number, don't jump into the answer. Okay, always look at the unit. Always pay attention to the units. Okay, that is important. So the correct answer is B. The correct answer is B. Okay. All right. So here's the detailed way of doing this, but I think you get the idea. So if you want, please pause and revisit the calculation. Okay. But by the way, please remember to get the answer in Celsius. Okay. Please remember to get the answer in Celsius because that is what they want. So I want you to do this study check really quickly. Okay. So pause the video now and try this. Okay. All right, so let's see. We have to complete this sentence using the word increases or decreases. So it is like, a elementary school exercise, but only thing is that you need to know the Charles law and Boyle's law. Okay, so first statement is that constant temperature and moles. So we are using what? We are using Boyle's law. Okay, so according to Boyle's law, V decreases if you increase the pressure, right? If you increase the pressure, so if you increase the pressure, V decreases. Okay, and B, if you so in here you have constant pressure and moles. That means we have to use Charles law. We are using Charles law, and then in here, according to Charles law, temperature and volume are proportional. So if one increases, the other increases, and vice versa. Okay, so here T decreases, so volume should what? Volume should decrease. Okay, volume should decrease. And in C, what you have is once again Boyle's law application, because in here the temperature and moles are constant, so use Boyle's law. According to Boyle's law, pressure and volume is inversely proportional. So volume is increasing, so pressure should decrease. And in D, you again use Charles law, because constant pressure and moles applies to Charles law. So temperature and volume are proportional. So temperature increases, volume should also increase. Okay, so that is how you do this. These are your answers. Okay. All right. So let's get to the final law, which is basically known as Gay-Lussac's law. This is the last law that we are going to talk about in this video. So in Gay-Lussac's law, we are keeping n constant, just like the other two laws, Charles law and Boyle's law. We keep n as a constant, but the only other property that we never kept constant from the last two laws are volume, right? So in here we are going to keep volume a constant. So Gay-Lussac's law applies to gases where the amount of a gas constant and also where the volume of a gas constant. So how do you keep those two constant? So we use a closed container, and also we make sure that this piston is not moving. Okay, this is not moving. Whatever happens, it remains as is. Okay, it remains as is. So this piston is not going up and down. Okay. All right. So in Gay-Lussac's law, we are going to learn the relationship between temperature and pressure. Okay. So let's say you're heating this container. Okay. So you're heating let's say you're heating or you're increasing the temperature of the container. So when you're increasing the temperature of a container, temperature is uh, temperature basically correlates to the kinetic energy of the gas molecules. So gas molecules starting to move faster inside the container. So gas molecules are moving very fast inside the container. So when they are moving so fast, they start hitting the walls more frequently and hardly, right? So the gas molecules are now hitting the walls more frequent, and also they are hitting harder on the walls, right? But the walls are, permanent boundaries, they are not moving. So let's say, when the gas molecules are pounding more and more on the walls, the pressure on walls increases, right? So basically, the thing that we can understand is that when you increase the temperature, pressure increases. Pressure increases. So if you decrease the temperature, the pressure should decrease. So what is the relationship between temperature and pressure? Temperature and pressure has a proportional relationship. Okay, so at constant amounts and at constant volumes, okay, uh, pressure of a gas is proportional to the temperature of a gas. Okay, the pressure of a gas is proportional to the temperature of that gas. So you already know that, we don't like proportional signs now, so we will replace the proportional sign using a equal sign, but it comes with a constant, of course. Okay, and then let's take temperature to the other side. Let's take temperature to the other side. So what you have is the ratio between pressure and temperature is a constant. Once again, K is a constant, okay? K is a constant. So according to Gay-Lussac's law, the ratio between pressure and temperature is a constant at constant N and V. Okay, so this is the equation that we have, but let's get rid of K. How do we get rid of K? We can apply this equation for two different scenarios, okay, two different states of the same gas at constant amounts and volumes, which means P1 T1 will be equal to P2 T2. So here is our new equation. Okay, here is our brand new equation. Okay, very similar to Charles law, which means temperature should be in what? Temperature in Kelvin. Okay, all your Celsius or Fahrenheit, make sure to convert them into Kelvin. Okay, make sure to convert them into Kelvin. So let's get back to our presentation. Okay, all right, so according to Gay-Lussac's law, okay, the equation that we got is P1 divided by T1 is equal to P2 divided by T2. We already know how we got this. You can either memorize it or you can derive it, just the way that I did it a few minutes ago. Okay, so basically the ratio between pressure and temperature is a constant, okay, at constant volume and N. Okay, so that is Gay-Lussac's law. Okay, that is Gay-Lussac's law. Let's do a quick study check. Okay, so solve Gay-Lussac's law for P2. So once again, they want us to rewrite this equation as a function of P2. So you want to get rid of T2, right? So you will cross multiply it and T2 will go to the top. So P2 equals P1 divided by T1. Those two, nothing happens to those two, and then you will also have a T2 term on top. Okay, you will also have a T2 term on top. All right, so this is the answer. Okay, so if you know how to get there, after that you will switch the three unknowns and then you will figure out you will plug the three knowns and then you will figure out the unknown. Okay, very straightforward. Here's a simple example. Okay, so this example is well explained in this PowerPoint presentation, so let me just go through it as is. So you have a gas at constant volume and moles, okay, which means N and V are constants, right? N and V are constants. We should use Gay-Lussac's law. Okay, we should use Gay-Lussac's law. Whenever N and V are constant, we use Gay-Lussac's law, which is P1 over T1 is equal to P2 over T2. Okay, we know that now. Okay, so we know the initial pressure and temperature, and then we know the final pressure, which is increased to to 62 degrees Celsius. So what should happen to the pressure? It should also increase. It should also increase. So if you plug the numbers into equation, okay, you can figure out P2 easily. But please remember to convert all the Celsius values to Kelvin values, okay? Please remember to convert all the Celsius values to Kelvin values. That is the only thing that you need to remember. So you will plug the knowns and then you will figure out the unknown P2. Okay, very straightforward. All right, let's do this study check. Let's do this one really quickly. So we know P1 and T1. We know P1 and T1. Okay, and then we know P2. Pressure is increased. So if the pressure is increased and we look at the constants, it is V and N. So if V and N are constant, we can use Gay-Lussac's law. Okay, so what is Gay-Lussac's law? P1 T1 equals P2 T2. Here's the thing, we know all the terms but T2. So we have to rewrite this equation as a function of T2, as a function of T2. So if you rewrite this equation as a function of T2, let me erase this. If you rewrite this equation as a function of T2, it will be T2 equals T1 times P2 P1. Okay, this is the equation that you get. And of course, you know all the terms. T1 is 401 Kelvin. Okay, 401 Kelvin. Remember, you have to add 273. Okay, you have to add 273 to it. So it will be 401 Kelvin. Okay, so 401 Kelvin. Okay, and then the final pressure is 824 torr. And then initial pressure is 645 torr. Okay, and you will plug the numbers in your calculator. You will get the temperature, of course, in Kelvin. Okay, but in this calculation they are asking for the temperature in Celsius. So if you want it in Celsius, simply subtract 273 from the answer. You will get the temperature in Celsius, which is 239 degrees Celsius. That is how we do it, guys. Okay, that is how we do it. All right, so here is the stepwise breakdown of the solution. If you want, you can pause the video and take a look at it, but it is basically the same thing that we just discussed. Okay, it is basically the same thing that we just discussed. And also I will let you do this study check by yourself. Okay, so take a second and then see if you can understand this one. Okay, with that I'm going to stop this video. So in this video we talked about 3 gas laws: Boyle's law, Charles' law, and Gay-Lussac's law. Okay, when we talk about all these 3 laws, okay, Boyle's law, Charles' law, and Gay-Lussac's law, in all these 3 laws we kept N as a constant. And then also from the remaining 3 factors, pressure, volume, and temperature, from the remaining 3 factors we kept one other factor constant. Okay, so N is always a constant, and then one of these is constant, and then we try to derive an equation from the relationship between the other 2 remaining factors, right? So we learned 3 new equations. So either you can remember the 3 equations, or my recommendation is that you try to derive it by using an understanding. Okay, but anyway, if you know these 3 equations, okay, you can easily use it in equations, and then you can figure out the unknown term. Okay, with that I'm going to stop this video. You guys have a good one. Okay, take care.